Let's take a look at two more sample trig problems. All right, so these are going to be problems 2 and 3 on your worksheet. So here we have, as shown in the diagram below, so this time they even give us a diagram. A ladder 5 feet long leans against a wall and makes an angle of 65 degrees with the ground. Find, to the nearest tenth of a foot, the distance from the wall to the base of the ladder. So as normal, why don't you try pausing this video and try filling out this problem? If you don't want to do it on your worksheet, grab a sheet of scrap paper and practice on there. So if you're right there, you can just copy it to your worksheet. If you're not right, you can clean it up with the example that you see me going through. But it's important for you to get some practice in on this yourself. Just watching me do a problem is kind of like watching somebody else exercise and hoping that your muscles are going to grow because of it. It doesn't work that way. So pause the video now and give this a good shot based on the reference works we have from earlier in this module. Well, the only thing we don't have marked in this diagram is the variable that we want to solve with. So they want us to calculate the distance from the wall to the base of the ladder. So the wall to the base of the ladder is x. Sometimes they'll ask for the height above the ground that the tip of the ladder reaches, and so this would be the variable you'd be looking for. You're just reading the problem and setting the variable equal to what they want. If you're able to skip steps here, you're going to see I'm not, but if you're able to kind of start seeing these things yourself, give yourself a hand for that. But also double check your work with me to make sure that what you're doing is correct. So if this is the angle that I'm focused on, this is my adjacent side, and this is the hypotenuse. So with adjacent and hypotenuse, I want to talk about cosine. So the cosine of 65 degrees is equal to adjacent over hypotenuse. So the ladder is x, and I'm sorry, the base is x, and the length of the ladder, our hypotenuse, is 5. So this is the sort of problem we were solving earlier in the module. Just need to get x alone. I'm dividing x by 5. So to isolate x, the opposite of dividing by 5 is multiplying by 5. So those 5's cancel out, and x is equal to 5 times cosine of 65 degrees. 65 cosine times 5. All right, and so what is the answer? Based on the number that I see here on the calculator and the instructions I have for the problem, what is the answer to the question they're asking? I want to find x to the nearest tenth of a foot. So here's the tenths place, and 2.1 I want to round down. Remember, rounding down from 2.1 doesn't mean 2.0, it means 2.1. I want to know, is this number closer to 2.1 or to 2.2? It's definitely closer to 2.1 than it is to 2.0, right? So here is the nearest number that's expressed in tenths that talks about the distance of the triangle. So this is 2.1 feet. Okay, and here's the second problem that I want you to do. Same story. This time they even give us the x. The only problem here is that they give us this angle of depression. Remember, the guy in the lighthouse is looking down. So this angle is looking down by an angle of 26 degrees. And so the only problem is that this 26 is not inside the triangle. So what do I do with that 26? Well, probably the easiest thing to do is to recognize that this horizontal line here is parallel to the sea. And so since these two lines are parallel, which angle inside this triangle is also 26 degrees? I got parallel lines cut by a transversal, and I've got that mark of Zorro. So this angle is also 26 degrees. So the angle of depression from somebody standing at the top of the lighthouse is same thing as the angle of the elevation of somebody standing on this boat here, assuming the person in the lighthouse and the person at the boat are looking at each other. So that's kind of cool. So now I've got my right triangle, and here's my three sides. So I've got 26 degrees, I've got 215 feet for the height of the lighthouse, and I want to solve for x here. So what are the names of these two sides, and which trig function am I going to use to express it? Well, 26 degrees, this is the opposite side, the height of the lighthouse, and this side over here is also a leg, and so that's the adjacent leg. So opposite and adjacent means I want to use the tangent function. So I know that the tangent of 26 degrees is equal to, tangent is opposite over adjacent, which is 215 divided by x. So all I need to do now is multiply both sides by x. So I've got x times tangent of 26 degrees is equal to 215. And now to get x by itself on this side of the equation, I need to divide both sides by the tangent of 26 degrees. So x is equal to 215 divided by the tangent of 26 degrees. 215 divided by 26 tangent is equal to, so what is the answer to the question that they want me to give for this problem? All right, so we're talking about feet. They want to determine to the nearest foot of x. And so this rounded to the nearest foot is 440, and we want to round up because 8 is bigger than 5. So that is equal to 441 feet. So solving word problems, I'm hoping you're seeing, is a very similar process to solving them when we're just given the triangle without all of the words. We just need to do a little bit of extra math and a little bit of extra reading in order to take that jump. So do the homework problem with a couple of word problems, and then visit me in a video afterwards, and we're going to talk about some trig word problems that are just a step harder than this, because we actually are going to need to think about two right triangles instead of just one.